Hey guys, welcome back to a new video, and in this video we are gonna make interaction system in Unreal Engine. And this system will not be limited for a single object. You can make any object interactable that you have in your project. And as you can see here, I can interact with different objects which does different thing when interacted. Like other than opening and closing the door, here I can pick up the items into a character's hand. And you can make your own logic on what should happen after you interact with the object. So this video is going to more like going to give you a structure for making interaction system in your game. And you can also download this project from my Patreon, where you'll find all the project files I've ever created for these tutorial videos, so do not forget to check that out. The link is in the description. So to do it, first in your content browser, let's create a new folder and let's name this blueprints. Since inside this folder, we're gonna keep all the blueprint classes for this video. So here, let's right click, and from here, let's create a blueprint class of actor type. Let's name this base interactable BP, because this is going to be a base class for all the interactable objects that we are going to have in a game. Like it is going to be a parent class of it. And the first thing we're gonna do is, let's add a static mesh component. Let's name this interactable mesh. And from here you can choose any asset that you want to make interactable. But since this is a base class, so I'm just gonna select this cube mesh just for the testing, because we're gonna change the mesh in its child blueprint, so doesn't really matter what you pick here. Now let's add another component, that is sphere collision. There you go. And from here let's increase the sphere radius a bit like this. Now this sphere collision is going to detect if a player is anywhere near this object. So when any object overlaps with this sphere, we can detect it using this onComponent begin overlap event. So this event is going to fire as soon as any object overlaps with this sphere. But here we want to ensure that the actor that overlaps with this sphere is a player character. So here just check if this other actor parameter is equals to this get player character return value. And if it is true, only then we are going to perform the further code. Alright, so now what we are going to do is, we are going to handle all the interaction related things in a separate blueprint. So here let's right click and in the all classes search for actor component. Here it is, select this and let's name this interaction component. So let's open this up, and this is where we are gonna write the logic about the interaction system. And before that, we are going to add this component in a character blueprint. So open up your character blueprint, and just like you have this character movement component, the same way we are going to add that interaction component. So search it here. Here it is. Now all the codes that we define inside this component is going to work with your character blueprint. But as soon as we remove this component from this character blueprint, the interaction system will stop working without breaking anything else in your project. And this way the code stays modular and more organized in your project. Now here let's create a custom event. Let's name this onInteractable overlap. Also here let's add an input parameter. Let's name this overlap and make sure it's a boolean. And we are going to call this event when we overlap with this sphere collision. And to access that event, first we need to get the reference of this interaction component. So for that, here since we ensured that the overlapped actor is a character, so from this we can get component by class. And here search for that interaction component. Now how this node works is, it's going to search for any interaction component in your character blueprint, and if it finds any, it's gonna give us that reference. And once we get the reference, we can access any event inside of that. And here we wanna call this onInteractable overlap. Now here let's check this overlap parameter, since we are overlapping in this case. Now here is one more thing. For suppose if the character is not using this interaction component, in that case, it is going to give us error in the runtime, since the component is not going to be valid. So for that case, before we call any event inside of that, first check if it is valid. Only then we are going to call any event inside of it. Alright, so now let's go with the opposite case. Means when the character goes outside this sphere collision. So to detect that, let's add an onComponent and overlap. So we are just going to copy all this code, and the only thing that we are going to change is just uncheck this overlap option. So here we'll know if our character has overlap or has an overlap with the interactable object. So if we are overlapping, we are gonna keep the counts of how many objects we are overlapping at the same time. So let's place this interactable object in the level. So here when our character overlaps with these sphere collisions, we are going to increase the count. And when character leaves, we are going to subtract it. So here let's create a variable. Let's name this overlap count and make sure it's an integer and set it here. Now if we overlaps, we are going to increase it by 1. So get overlap count and add this value by 1. But if the condition is false, we are going to subtract it by 1. So this way we can keep the track of how many objects we are overlapping. Now instead of using branch, we can use select operator in which we can give different values based on if the condition is true or false. So plug it to the add operator. So if the condition is true, then we are going to add 1, and if it is false, then we are going to add -1, which is eventually going to subtract it. Now just for the debugging purpose, let's print the value before we play test this. Here you can type a command of show collision to see all the collisions in the level. And as soon as we overlaps with the collision, on the top left you can see the overlap count. And if I stand just at the middle of both of them, you can see the overlap count is 2. And it subtracts as I move away. So this way we can keep the track of how many interactables we are overlapping at the same time. But now we have to detect if we are looking at a specific interactable. So to do that, here in the overlap event, let's add a sequence since we are gonna perform one more code simultaneously with this. And for that, we are gonna create a separate custom event. Let's call this draw trace. And also let's add an input parameter and name this draw trace. Make sure it's a boolean. And we are gonna call this event in this overlap event. Now the reason we name this event draw trace because it's going to do the exactly what it says, that we are going to draw a trace starting from the center of the viewport, and it's gonna end some units away in the direction of where a character is looking. So if the trace hits any object between this distance, then we'll be able to detect if we are looking at a specific object. Now based on this draw trace parameter, we are going to either start or end the trace. So for this, the condition will be that the overlap count should be greater than 0. Means we must be overlapping with some object, at least one. Alright, so now let's here check if the parameter value is true. If it is true, then let's set timer by function name, and I'm gonna explain this in a minute, but before that it needs a function name. So for that, let's create a custom event. Let's name this detect site because that's what we actually wanna do. And let's copy the name of this event and paste it here. And here set the time to 0.1 and check this looping option. Now what this timer node will do is, it is going to call this event again and again every 0.1 seconds in a loop. And it will keep calling that until we stops it. And that's how we are going to keep drawing the trace to keep checking if we are looking at an interactable object. Now from this return value, let's promote this to a variable. Let's name this trace timer. Now at some point, we want to stop the trace, right? And we are going to stop it when we are not overlapping with any object. So basically, if this condition is false, then we are gonna stop the timer. So just search for the clear and validate timer, and this is going to stop calling the event. So now to draw the trace, let's search for the sphere trace by channel. And it needs a start location and an ending location. So as I told you before, the start location is going to be like here at the center of the screen, and the ending location is going to be some units away where a character is looking. Now here, get the player controller. And from this, get the viewport size. Now this is going to give us the viewport size like horizontally and vertically. So we are just going to divide them by 2. And this is going to give us the center of the screen, if that makes sense. And here from the player controller, search for convert screen location to world space. And it does what it says. So here just give it the screen X value and Y value. Now this world location is going to be the start point of our trace, which is the center of the screen converted into the world space. And for the end location, it is going to be some units away in the direction of where our character is looking. So here from the world direction, we are going to multiply it, and here right click and convert it to float. And let's say we want to keep the trace 250 units away in the direction we are looking. So the detection length is quite long, and then we are going to add it with its world location, and that gives us the end point of the trace. Here let's keep the radius to 5, and to actually see the trace, here we can set this to for duration, and the draw time we are gonna keep is 0.1. Now here, to make the code a little bit cleaner, we can do one thing is select all this code, right click and collapse into a function. Let's name this calculate trace start end, and you can check this pure option so there will be no execution pin with it. And if you double click on the function, you'll see all the code is been collapsed inside this function. Alright, so now we're gonna check if the trace has hit any object or not. So if the trace has hit anything, then let's break this hit result, and this is going to provide us a whole lot of information about the trace. But here all we want is this hit actor, because here we want to check that the trace that hit the object is an interactable blueprint. Now to identify these interactable objects with different objects in the level, here we can do one thing is we can add a tag. Let's name this interactable. And now here we're gonna check if that actor has that tag. Just put that tag name here, and that's how we can identify if it is an interactable blueprint. Now once we ensures that this trace only detects the interactable objects, so now what we are going to do is, let's promote this hit actor to a variable and let's name this interactable object, and we are going to store the hit object into this variable. Now since we did that, that just means we are looking at the object, and that also means we can interact with that object. So for that, let's create a variable. Let's name this can interact. Make sure it's a boolean, and right here set this to true so that we'll know if we can currently interact with the object or not. Now if any of these condition fails, like if the trace did not hit anything or it is not an interactable object, in that case we are just going to invalidate this variable in which we have stored the previous interactable object, and also we can't interact anymore. Now before we test this, let's print the string for each condition. This one says it's looking and this one says not looking. So let's go near any object, and if we look at it, here you can see it says looking, and if we look away, it says not looking. So the site detection is working. Now here the issue is that we are setting this information again and again every 0.01 second, but we don't really need to until we change where we're looking. So to fix that, what we are going to do is, we are going to check if the hit actor is equals to the interactable object. That means the current object we are looking at, is it equals to already stored one? And only if it is not, that means we are looking at a new object. Only in that case we are going to set the information again. And for this below condition, we are going to check if this can interact boolean is true. If it already is, in that case we are going to invalidate the information. So now if we go near any object and look at it, you can see it doesn't print the message again and again. That means we are only setting the information when we actually need to. So this way we have optimized our code a bit. Alright, now what we want is, like when we are looking at the interactable object, we maybe want to highlight its outline, maybe show a tooltip UI like press E to interact and all. And to do all that stuff, what we are going to do is, in your base interactable BP, here let's create a custom event and let's name this onHovered. So when we are looking at the object, we are gonna call this event, and inside this we are gonna write all the logic that we want to perform when we are looking at the object. Now to call this event, here in your interaction component, we have this indirect reference of the interactable object, and to call that event, we need to cast to a base interactable BP, and then we can call that event. But the casting can be a little expensive for the performance of the game, and to avoid that, we can use blueprint interface. So to keep our blueprint interface, let's create a separate folder, and inside this, right click in the blueprints, select the blueprint interface, and let's name this interactable BP interface, since I'm creating this one for the base interactable blueprint. Now let's open this up and let's name this function onHovered. Then let's add another one and call this onUnhovered. So now we have these two separate functions for hovered and unhovered events for our interactable objects, and we are going to use this instead of this event. And to define these functions inside our base interactable BP, first we need to add this blueprint interface in this class. So go to your class settings, and from here add that blueprint interface. That is our interactable BP interface. There it is. And now you can define those functions inside this blueprint. Just search for them, and here you can see now you can define these functions in this class. And they are just like any other custom event we use in a blueprint. And the best thing about using blueprint interface is that we can call these events so easily in another blueprints. Like we don't need any hard reference of any class to access those events. And as you can see here, we have this generic actor reference of the interactable object, and we can still call that onHovered event. So just like that, we can call every event related to when you hover at the interactable object, and the similar way we need to call the unhovered event, and we need to call it just before we invalidate all the information. And just to avoid any runtime error, let's convert this to a validate get, so it only calls the event if the reference is valid. Alright, so once we did that, now we need to unhover the object before we hover the new one. So just paste it here so that it will unhover the previous interactable object it has stored. Alright, so now in your base interactable BP, you can write logic for these events, since they are gonna fired when we are going to look or remove a site from these interactable objects. Now you can do whatever you wanna do when you hover or unhover on your interactable objects. But just to show you what I'm gonna do is, I'm gonna display a tooltip UI at top of this object so the user will know which key to press to interact with the object. So for that, here in the content browser, let's right click and let's create a user widget. I'm gonna name this tooltip UI. Let's open this up. Now first of all, let's add a canvas panel. Then let's add a border and let's give it some rectangular shape like this, and I'm gonna give it some dark color with the half transparency. Now let's add overlay in this border so that we can add multiple elements inside this border. And the first element I'm gonna add is the image. So drag it under the overlay and let's align it horizontally center and vertically at the bottom. Now I'm gonna use this image since I already had this available. You can use any image you want. Let's adjust the size a bit. Then let's add a text, and the text is going to be press E to interact. I think that's okay. Let's align it at the top and also add some padding from the top. There you go, looks fine to me. And now you can adjust the canvas size, or you can add a custom size from here, and let's just give it some appropriate size so it won't cover the whole viewport. There you go. Now let's go back to a base interactable blueprint, and here let's add a widget component. Now drag this widget component under the interactable mesh. Now in the details panel, scroll down until you find this user interface category, and here in the space, select screen, and from here select that tooltip UI that we just created. Now move this widget component a little upward so it will show the UI at the top of this object. Now one more thing we need to do here is we need to uncheck the visibility option from the details panel, since we are gonna hide this UI by default and only gonna show it when we hover at this object. So set the visibility to true for this tooltip UI and copy the same node for the unhovered event, and here we are going to hide it again. Alright, so now one more thing that I'm gonna do when we hover is I'm gonna highlight the outline of the mesh. So for that I have this event, and then I'm gonna unhighlight it when unhovered. Now this event I have defined already just for the tutorial purpose, and all it do is just highlight the outline of the mesh. And you can do anything you want. I'm just showing you what you can do, but it's your game, so you wanna do whatever you want. And the thing is that this is a base class. So because we are going to create child blueprint of this class, all the code that we define here are automatically going to be inherited into its child blueprints. So the tooltip UI and the highlight feature will be inherited and work for all the interactable objects we are going to have in this project. Now let's play and test this. So now as we hover at any interactable object, you can see it highlights and shows us this tooltip UI. You can see it works quite well. But there's an issue that I found, that when I goes away and it stops drawing the trace, it just remains hovered. The solution is simple. In the interaction component, here when we draw the trace and the condition is false, here we also need to invalidate the information just like we are doing in the unhovered state. So just copy all this code and paste the same for this condition. Now here one more thing I would recommend to do is, as this timer is already running and we might call the draw trace event again, it can cause some conflicts. So just to avoid that case, we can check if this trace timer is already valid, and only if it is not valid, then we are going to start the timer. And to stop the timer, the trace timer should be valid. There you go, now it should work fine. So now if our player leaves while hovering the interactable object, the object gets unhovered, and that issue has been solved. And now just like hovered and unhovered event, we are going to add one more function here in the interface, and let's name this interact. So like this is the main function we were waiting for, that will fire when we interact with the object. Now more on that later on. First let's add an input parameter, and let's name this character, since we are gonna give the character reference as the parameter to this event. You can set the variable type to actor object reference, because while calling this event we might not have the hard reference, so let's just keep it generic. Now let's define this function in a base interactable BP, and just to ensure that it fires, let's print a string and let's print interact. And you can also define any logic for interaction, but since this is a base class, I'm not going to define the logic here, but in the child class. But before we go into that, let's go into your interaction component, and here we are gonna call that interaction event when we press, let's say, the E key. So let's call this event. Just search for it, and there you go. Now the target is our interactable object. So here we have this generic actor reference of it. So just plug it here. So it's gonna work. And here we are going to give it the character reference. And how we're gonna give the references, since we know we are using this interactable component in this character blueprint, that means this character blueprint is the owner of this interactable component. So just get owner and plug it here. and it will be a valid reference for a character. Now this is not any proper way of setting up the inputs. I'm just doing this for the tutorial purpose. If you want to set up inputs properly, for that first we need to create an input action for the interaction. So just right click and in the inputs, create input action. Let's name this IA interact. If you open this up, just make sure the value type is of boolean. So it just takes input as pressed or not pressed. Now in your input mapping context, add an input mapping and select this IA interact which we just created, and for this let's assign the E key. So now when we search for IA interact, we will get this input action event which we are going to use instead of this E key and plug this started execution pin, and this is going to trigger when we press the E key. Now here one thing we need to ensure before we call this interact event, that the object should be available to interact. So if this can interact boolean is true, only then we are going to call this interact event. So now let's test this if this works. Alright, so now if I hover over this interactable object and press E, you can see it's printing the interact message. And if I press E while not looking, it won't print anything. That means it's working fine. And now we are done with setting up the base interactable class. And now it's time to create child class of it. So for that, I have plenty of assets, those I wanna make interactable, like this store or this chest, and I have plenty of others. So to make them interactable and to have their own logic on interaction, we are going to create the child blueprint class of this base interactable. You can also create the child blueprint class the other way. Just click on blueprint class and in the all classes, search for the class you wanna make child class of. In our case, it's base interactable. And let's name this door pp, since we wanna make this one for the door. Open this up. And here you'll see it's the exact copy of its parent class, which is base interactable pp, because all these components and all the logics in the event graph are being inherited into its child blueprint, as you can see here. So we don't have to write logic again and again for every blueprint class. Just simply make the child blueprint of it. Now all we need to do here is just select your door mesh. There you go. Let's shift this at the center, and here we are also going to add one more static mesh for the door frame. There you go. Now the door should have its own logic when a player will interact with the door. That will be opening of the door. So we are just going to do that. So to write the logic, go to event graph, and here we can call event interact, which is inherited from its base class. So the event will fire the same way. Now if you also want to execute the code that is in the parent class, for that just right click on the event and add call to parent function. And now this will call the code that is written in the parent class first, and then you can write your own logic. So I'm just gonna call it just to show you guys. It totally depends on you. So now we can write the logic about opening the door. And for that I'm gonna create a separate custom event and then later call this event in the interact event. And after you are done with writing the logic for the interaction of this object, you can simply call that event in this interact event. Now let me quickly show you guys how it works. So this event takes an input parameter to check if we want to open or close the door. And based on that, it set this boolean value that we created just to keep the track. And then we run this timeline, which is having this smooth curve for the smooth opening of the door. And it starts from 0 time and 0 value to half time and 1 value. And we get that graph value from this and we multiply it with 90. Since we want to rotate it 90 degrees to open the door. And the thing that we want to rotate is the interactable mesh, which we are rotating at the z-axis. It's a pretty simple logic and we go back and forth based on if you want to open or close the door. Now to toggle between opening and closing of the door, here we can just get the open boolean and get the not operator and plug it here. So if the door is opened, it will close, and if it is closed, it will open. And one more thing we are gonna do is just make sure that this tooltip UI is just at the right place. So I want it near the knob like this. And now let's place this door in the level and test this. So if I go near the door, you can see it hovers with this tooltip UI, and let's interact with this. You can see the door opens, and on interacting again, it closes. Even though we just wrote the logic about opening and closing of the door, the whole interaction logic that we wrote for its parent class is working along with it. And now it's so much easier to turn any asset into an interactable object. All we need to do is just create the child blueprint class of this base interactable BP. And now this one we are gonna create for the chest. Let's open this up, and just like before, select your mesh and write your logic for the interaction. Now for this chest, the logic is quite similar as the door. We just need to rotate this thing. So just like we did for the door, get this event interact, which is gonna fire when we interact with it, and create a separate custom event to open the chest. Now since the logic is quite similar, we can just simply copy it from the door blueprint and paste it here. The only thing we're gonna change is the rotation value here and the axis we want to rotate on. Now simply call this event in the event interact. Now let's place this chest into the level. And now if we play, you can see the interaction logic is also working great for this chest. Here just make sure to set the tooltip UI at the right place. And in your interaction component, we can turn off this debugging sphere trace since we don't want to see it while it's drawing. Now you can create as many interaction classes you want for your game. Like I'm gonna give you one more example. Let's say we want to make pickable items in a game. So for that I can create a base pickable class from this base interaction BP, which is going to be a parent class for all the pickable items we are going to have in a game. So let's open this up. And inside this, we can write the logic about picking the items that is going to work for all the pickable items in a game. Like you can get this interact event. And to pick up the item, let's create a separate custom event that will execute the code for picking the items into the character's hand. And for this case, we are gonna need the reference of the character. So you can give it the input parameter and we are going to call this event when we interact with these items. Now since this video is getting quite long, I can't explain the interaction logic for every item, but I think I've did the job and now you have the understanding of how the interaction system works. And if you wanna know how to make an item pickup system, I've already made a video about it. Just go through my channel and you'll find it or you'll get the link in the description. But let's continue with the example. So like when you're done with your logic and all, then all you need to do is just create the child classes of that blueprint and all the logics that you wrote in the parent class will be inherited into its child classes. So here I am done with setting up the child classes of the pickable items, just how we did for the door and chest, and now let's place them into the level. And just so you know, these pickable items are like grandchildren of that base interactable BP. So yeah, that's how inheritance works, and you keep introducing new features with every child class. And now with this interaction system, you can interact with any object you want with their own interaction logic. And this is like a structured way of making interaction system in your game. So I hope you like this video, and if you do, you can support me on Patreon, where you can download this project files along with many other project files I've created for these tutorial videos, and also you can support me there so I keep making these tutorial videos in the future. And you can also join my Discord server where you can interact with other developers of this community. All the links are in the description. And if this video helped you out, you can like and subscribe to my YouTube channel. And I want to thank the Patreon members of this month. Thank you so much for your support. It really means a lot to me. Alright, till then, see you. Bye bye.